When learning about the primary elements of architecture, we must first look at the atoms and nucleus of design, which are the conceptual elements of point, line, plane, and volume. As conceptual elements, the point, line, plane, and volume are not visible except to the mind's eye. While they don't actually exist, we nevertheless feel their presence. We can sense a point at the meeting of two lines, a line marking the contour of a plane enclosing a volume, and the volume of an object that occupies space. As we experience these forms in our environment, we should be able to perceive in their structure the existence of the primary elements of point, line, plane, and volume. This week, we will only explore point and line. Now, point marks a position in space. Conceptually, a point has no length, width, or depth, and therefore is static and directionless. As a primary element in the vocabulary of form, a point can serve to mark the two ends of a line, the intersection of two lines, the meeting of the lines in the corner of a plane, or the meeting of the lines in volume. Although a point theoretically has neither shape nor form, it begins to make its presence felt when placed within a visual field. At the center of its environment, a point is stable and at rest, organizing surrounding elements about itself and dominating its field. However, when the point is moved off-center, the visual field becomes more aggressive and begins to compete for visual supremacy. Visual tension is created between the point and its field. Since a point has no dimension, to visibly mark a position in real life, we need to project the point vertically into a linear form. You can see this done in architecture through column, obelisk, or a tower. In elevation, a column, obelisk, or tower would look linear, but on a plan they would look like points and therefore retains the visual characteristic of a point. Other point-generated forms that share the same visual attributes are a circle, like the plan of the Tholos of Polykleitos in Greece, a cylinder, like the Baptistery of Pisa in Italy, and a sphere, like the Laguardia in France. On the other hand, 2 points are a whole different story. They can describe a line that connects them. Although the points give this line finite length, the line can also be considered a segment of an infinitely longer path. 2 points can create an imaginary line that creates an axis between them, such as the mall in Washington, D.C. When axes exist from the Lincoln Memorial, the Washington Monument, and the United States Capitol Building. 2 points can also suggest an axis. An axis occurs perpendicular to a symmetrical line. Because this axis may be infinite in length, it can be at times more dominant than the described line. In plan, 2 points can also indicate a gateway that signifies a passage from one place to another. When the 2 points are extended vertically, like the Torii, it can define both a plane of entry and an approach perpendicular to it. Now, to make a line, all we have to do is extend a point. Conceptually, a line has length, but no width or depth. While a point is by nature static, a line, on the other hand, can express direction, movement, and growth. It can serve to join or link visual elements, support, surround or intersect other elements, describe the edges of and give shape to planes, or articulate the surfaces of planes. Although a line theoretically has only one dimension, it must have some degree of thickness to become visible. It is seen as a line simply because its length dominates its width. The character of a line, whether taut or limp, bold or tentative, graceful or ragged, is determined by our perception of its length-width ratio, its contour, and its degree of continuity. Even the simple repetition of like or similar elements, if continuous enough, can be regarded as a line. The orientation of a line affects its role in a visual construction. While a vertical line can express a state of equilibrium with the force of gravity or symbolize the human condition, a horizontal line can represent stability, the ground plane, or the horizon. An oblique line is a deviation from the vertical or horizontal. It may be seen as a vertical line falling or a horizontal line rising. It is seen as dynamic and visually active in its unbalanced state. Vertical linear elements such as columns, obelisks, and towers have been used throughout history to commemorate significant events and establish particular points in space. The column of Marcus Aurelius, for example, in the Piazza Colonna in Rome, commemorates the emperor's victory over German tribes north of the Danube. The obelisk of Luxor in Paris, on the other hand, marks the entrance to the Ammon temple at Luxor in Egypt and was given to Louis Philippe and moved and installed in 1836 in Paris. Vertical linear elements such as minarets at a mosque can also define a transparent volume of space between them, as seen in the Istanbul Kamlika Mosque. Linear members that possess the necessary material strength can perform structural functions. For example, express movement across space as seen in the Golden Gate Bridge in America, provide support for an overhead plane as seen in the caryatid porch in the Erechtheion in Athens, where the sculptural female figures stand as a columnar support for the entablature, or form three-dimensional structural frame for architectural space. Example seen here at a construction site in Milano, Italy. Buildings can also be linear in form, particularly when they consist of repetitive spaces organized along a circulation path. As illustrated here in the Louisiana of Modern Art in Denmark, linear buildings' forms have the ability to enclose exterior spaces as well as adapt to the environmental conditions of a site. Although architectural space exists in 3 dimensions, it can be linear in form to accommodate the path of movement through a building and link its spaces to one another. At a smaller scale, lines articulate the edges and surfaces of planes and volumes. These lines can be expressed by joints within a building or between building materials, by frames around windows or door openings, or by a structural grid of columns and beams. How these linear elements affect the texture of a surface will depend on their visual weight, spacing, and direction. So I'm sure when we started this lecture, you must be wondering, why are we learning about points and lines? And how could that possibly be associated with architecture? I hope that after watching the whole entire video, you understand the fundamentals of architecture start from the simplest things, and that from now on, you start to see points and lines everywhere you look.